Hello, welcome to exam practice medley. This is question 12. Now, I really love this question. If you recall, this was our last topic of the unit 1. Is related to reactance and impedance. Okay, so let's get started. Okay, so what I see is an AC current. So something you need to notice, this is AC. Okay, so it's a sinusoidal voltage supply, and then you got something, a curly line like this, and that's the inductor. Okay, so this is the inductor, just a reminder. And what is it connecting to? It's connecting in series with a resistor. Okay, so this is exactly what we taught in lessons, and if you would like to refresh your memory, is on page 75 of the revision guide, and that will give you a quick one-page summary. So in the book we talk about things in series, and then we can solve anything really. So it's asked to solve the current drawn by the supply. Well, we know that current is equal to voltage divided by the resistance, but the resistance is not just the resistor on its own, it's the combination of the resistance and the inductance. So therefore, we usually denote this resistance as in the impedance. So we use impedance. Okay, so if you recall that the letter Z, then you would know what we're talking about here. Okay, so the goal is to find the impedance, because we know the voltage but we don't know the impedance as yet. So that's your first goal. Okay, so how do we start? Well, to find the impedance, you have to use something called the ZL equal to, it's like the Pythagoras theorem I mentioned, XL square plus R square. Okay, so that's your resistance, and you need to find the XL. What's XL then? Well, XL, and we're working actually backwards, by the way, so you can see what I mean. I can quite nicely start with this, but you may have no clue why I start with XL, and this is the reactance. So you can also find the capacitive reactance if this was a capacitor. So in exam, just be careful. There will be another version where instead of inductors, it could be a capacitance. You will have XC instead then. Okay. So anyhow, so therefore, my step 1 really is to find what XL is. Then I can go and put that in here to find ZL, and my ZL is this Z, and then do the V over this Z I worked out, I get current. Okay, so let's get started then. So let's go and start with a different color. So XL, well, I hope this comes in the formula sheets. I'm not quite sure. If it doesn't, then you have to learn it. It's not too hard. So it's got 2 pi F, which is omega, times L. Okay, so some books, especially if you do A-level physics, they will do omega L, because omega is 2 pi F. Okay, so what's the L? L is the inductance. So L is this value. So it's the inductance. So therefore, 2 pi times F. What's my frequency? Well, 50 Hertz. F is 50 Hertz. Hertz is already an SI unit. That's lovely. So we times that by 0.6 Henry, and again that's already in SI unit. If it's millihenry, you got to put 10 to the power minus 3. So put that in the calculator. Try not to round your answer, because you need this value for further calculations. So 2 pi times 50 times 0.6. So I'm going to write that as 60 pi for now. So 60 pi. So think about the units as well. Reactance. In this case, you could use, because this is in Hertz. Hertz is per second. and this is Henry, so we can write Henry per second. Okay, because frequency hertz is how many per second. Okay, how many times it happens in a second. So yeah, so it happens 50 times. The oscillation happens 50 times in 1 second. Okay, so XL is that then, that's sorted. So we can now work out what ZL is. In fact, instead of writing ZL, write Z. Okay, so put that in. So XL is 60 pi square plus my impedance, which is 10 square, and then again put that in the calculator. Because I already saved that as my answer, I could simply do square root of my answer and square, and then add 10 square equal. Okay, so let's tidy that up. Okay, so 188.7606311 ohm. Okay, all right, so we got the impedance now. So now we just have to do 230 divided by 188 point something. So therefore the current is equal to 230 divided by the answer above, and therefore that will give me, so again that is saving my answer, so I can do 230 divided by my answer, therefore 1.218 amp. Okay, so we round that to 2 decimal place, so 1.22 amp, and that's your current. So that's sorted. 7 marks. What a generous question, if you know how to do it, of course. But having said that, now you've seen how I've done it. Hopefully you agree with me. This is pretty straightforward. Okay, it's not maths that would scare me at all. Certainly, I suppose you would agree that this will be better than factorizing, I guess. Okay, look, 1.22 amp. So they did write the answers, but I think on here they probably accept equivalent answers, like using pi, for instance. I can't see why they would take your marks off there. Okay, so there we are. Thank you.